In this video, we're going to take a more in-depth look at the domain and ranges of quadratic functions and their square root. So to start, let's take a look at the graphs, because I think that actually looking at the graph to compare the domain and range is actually a lot easier than trying to visualize it in your head. So to do this, locate some key points, and those key points are the intercepts and also the max or minimum. And then these points will then help you find the domain and range. So let's start by looking at this first example here. We have 5 minus x squared, and then we have y equals the root of that. So to graph, let's first rewrite this as negative x squared plus 5. That will give you a better idea that this has a vertex of 0 and positive 5. So I'm going to first plot that point here. And then the next thing is, because there's no stretch, no vertical stretch or horizontal stretch, it is flipped upside down, we can actually just use the ratio that it's going to be 1 over and 1 down, 2 over, and then 4 down, because it's a straightforward parabola. So we connect these 5 points to draw a parabola. Now let's graph the square root. So the square root, all we have to do is actually, we don't have to do a table of values. We can just take the square root of the y values that we already have. So this is 5. So the square root of 5 is about 2 point something, a little on the lower side, so 2.2-ish. 4, the square root of 4 is 2 on both sides. And the square root of 1 is still 1. So we can connect these 5 points here. But don't forget that between 0 and 1, it's going to be a little bit above the parabola, so I'm going to exaggerate that. And on the other side as well. So I'm going to exaggerate that a little bit too. Now hopefully you can make yours a little bit nicer than this. This doesn't look that smooth. All right, so let's identify the domain and range. So from here, we can see that from the original function, the domain is all real numbers. And the range is less than or equal to 5. Now, to help us identify the domain and range of the square root function, we actually need a little bit more information. So we find that, so I'm going to point this out in a different color here. We have these intercepts here, and this maximum value here. So in terms of the domain, we know that it's between these two x-intercepts. So to find these x-intercepts, we know that the y value is 0. So we're going to set the y value to be 0, and that equals 5 minus x squared. So we have x squared equals 5. So x equals plus or minus 5. So that means that this point on the negative side, that is our negative root 5. And the point on this side, on the right side of the y-axis, that's going to be our positive root 5. So knowing our intercepts, or x-intercepts, we know that the domain is between these 2 points. So we can say that the domain is between negative root 5 and positive root 5. Now for the range, we are going to look at our max and min. So our maximum value before was 5, but now it's root 5. And it doesn't go any higher than this, but we also know that when we square root a number, the smallest number we can have is 0. So actually our range is actually only going to go from 0 to 5 to root 5. So again, it is squeezed. So the y value is squeezed in between 0 and root 5. Okay, let's take a look at another example. So here we have half x squared minus 3. Now maybe to help you a little bit, if you would like to use a table, you can. Or what you can also do is take half of all of our x values to help you. Now to do this, we start off with our vertex 0, negative 3. And if you recall, because we have a fraction of a half and our denominator is 2, I kind of want to have numbers that work really nicely. So I'm going to skip count by 2's in the x direction so that when I square it, it'll always be divisible by 2. So I'm going to choose -2, -4, and +2 and +4. So when I plug in -4, it's going to be 16 divided by 2, which is 8, minus 3, we get 5. And that is actually the same when I plug in +4. 4 squared is 16, divided by 2 is 8, minus 3 is also 5. Plug in -2, I square that, and I get 4. 4 divided by 2 is 2, 2 minus 3 is -1. And same with when I plug in 2. So graphing this one, we get something that looks like this. And let's connect our 5 points together. Oh. Try that again. All right, so now that we have our 5 points together, let's see if we can figure out what the square root is. Now remember that again, the square root, we have to take the square root of just the positive values. So all the values underneath the x-axis, they don't count because they're going to all be negative. So I know that the square root of 0 is 0. So these 2 points are still going to be the same. And same with 1. Now, it doesn't actually occur right exactly at that point. We also have the square root of 4, which is approximately here. So that's going to be 2. And same on this side. So this is 4. So square root of 4 is 2. So we're going to follow it down to here. And I'm not sure why my pen isn't working like that. All right, let's try one more time. So square root of 4 is 2. So we're going to put our point there. Okay, so we're going to connect our 3 points both on each side. Remember, there's nothing in the middle part because this is all negative. So don't forget that between 0 and 1 is going to be a little bit above the graph. So I'm going to draw this a little bit above. And then going to the right. And on the left side, this is going to be a little bit above. And then going to the left. All right, so let's take a look at our domain. So again, our original graph has a domain of all real numbers because it opens on and on to the left and the right. And the range is going to be y is greater or equal to -3. Now again, let's try to find our domain. And this time we can see that our domain starts at these 2 x-intercepts here, but one part of it now goes left and the other part goes right. We're going to do the same thing that we did in the first one. To find our x-intercept, we're going to set y equal to 0, and then we're going to solve for x. So we're going to have 3 equals half x squared, and then x squared is equal to times both sides by 2. So 3 times 2 we get 6. So x equals plus or minus root 6. So again, this is going to be our negative root 6, and this will be our positive root 6. Now this time, instead of the graph being in the middle part like that first one was, it actually is from negative root 6 and then to the left, and root 6 to the right. So to write this domain here, we're going to say that x is less than or equal to negative root 6, and also x is greater or equal to root 6. Now in terms of the range, we start at 0 because remember the smallest value is 0 here, but then it just keeps on increasing. So for the range here, we can say that the y value is greater or equal to 0.